Hey guys, so welcome back to the channel. I know it's been a long time I have created a video. Uh, a subscriber reached out to me via my email. He wanted me to create a video on the singly linked list, a complete video on the singly linked list with the following functions that he mentioned. So I also thought that why not to create a video as the previous video only had a basic template implementation for the singly linked list and only a few basic functions which were to insert a node at head, tail, and a function to display the linked list. So in this video, I will not be using the template implementation of a single linked list. I will be using a simple single linked list implementation of for integer data type. And then what we will be doing is that we would be creating multiple functions for our linked list class that are really helpful and that you should know while studying the linked list data structure. So let's start off. Yeah, so I need to open my folder. Yeah, so now let's create our file and name it as singly linked list.cpp. And now let's include our headers. Yeah, so now first of all we need to define our node class, in which we need to have only two public member variables that will be our data that our nodes will be holding and a pointer to the next node. Now for the constructor in this class, I need to pass it the data, and along with that I need to initialize this data to be equals to data and the next pointer to be equals to null. Okay, so we are done with our node class. There's a bit of spelling mistake. Yeah, so now moving on to our main class, that would be our linked list class. So now inside this linked list class, what we want to have is basically the pointers for a linked list and a size variable that keeps a track of the size of our linked list. So for the pointers that we need to have of a linked list, we need to have a head pointer that points to the head of our linked list and a tail pointer that points to the tail of our linked list. So keeping those members as private member variables. So a head pointer, a tail pointer, and a size variable. And now inside our public member variables, we need to first of all have a constructor for our class without any arguments, a default constructor. uh, I need to initialize head to be equals to the null pointer, tail to be equals to the null pointer, along with the size to be equals to 0. Yes, and now moving on, what we want to now have is a function that inserts a node at the start of the linked list. So now let us name it as insert at start. So it will be having a return type of void insert at start. So for this function, I need to only pass it the data that we need to insert at the node. So the base case, so before the base case, we first of all need to create a new node. So I'll name it as new node. By the way, let's name it as a a temporary node, because new nodes gets uh, confused a lot with the new function that our C++ by default has. So a lot of students get confused over there. So why not to name it as temp and then initialize it as the new node with the following data. So I'll comment out the code as well so that you guys know it. And now we need to check that if our list is empty at first. So our list would only be empty if our head would be equal to the null pointer. So we use the comparison operator, and if the LL is empty, LL stands for linked list. So if the head is equals to null pointer, if it is true, then what we want is that we need to initialize our head and tail pointers to be equal to the new node that we have created. So head should be equals to tail, and it should be equals to temp. Right. So now for the else case, if the linked list is not empty, if not empty, what I want to do is that I want the new node to point before the head of the linked list, and then I want my heads to be equal to the new node. So basically what we want is that we want the new node to be awaiting before head. So we want temps next to be pointing towards head, and then when temp next points towards head, that means temp is before head, and what that means is that temp is actually the head of the linked list. So now what the only statement we would need to be executing is that we would just need to update temp to be equals to head. So now for this function, for this else case, we can write that temps next should be equals to head. That means temp is before head, and now just we need to update head. So head is equals to temp. That will do the job. And yeah, don't forget to increment the size of the linked list as well. Okay, so we're out of function, sorry. Yeah, so after this, moving on to the inserting at end of the linked list, or what you may refer it as insert at tail. I'll rather write as insert at end, so that we maintain a good writing order. So again, it will have the same data passed, argument passed for this function too. And again, we also again need to check that if the linked list is empty, and we again need to initialize a new node. So for that, I'm going to copy this part and paste it right here. So the only change that we will have is in the else case. So as you guys remember that for the insert at start function, what we did was that we pointed our new nodes next to head. But for this function, we want to insert a new node uh, after the current tail of the linked list, so that we update it to be the tail of the linked list. So in this case, we want to point the current tail of the linked lists next to be equals to the new node. So let me comment out if not empty. So what we want is that we want tail next to be equals to temp, and then we need to update tail to be equals to temp. So yeah, we successfully inserted a new node at the end of the linked list. So again, we need to increment the size of our linked list, and now I would be creating a function to basically insert a node at any position, and we will be handling 3 edge cases over there. So naming it as insert at uh, just a minute, insert at position. So to insert a node at any kth position in a linked list, we need to pass it the data. Along with that, we need to pass it the position. We need to pass it 2 arguments. So the most brute force thing that we can think of, right, is that if the position should be, so if the users enters the position to be any number which is negative, or any number which is greater than the current size of the linked list, that would be considered an invalid position. And if the user enters the position to be equals to 0, so that means he's pointing to the head of the linked list. So we will simply call the insert at start function, and if the position is entered, if the position entered is equals to the size of the linked list, so that means it is referring to the end of the linked list. So we will simply call the insert at tail function, and then for any other position in the middle of the linked list, what we need to do is that we would create a new node, and then we also need a pointer to store our head pointer so that it doesn't get lost. And then we will run a for loop which will simply run till the position, and then we will just do some manipulations with the nodes, and we'll successfully insert a new node at any position. So now first of all, starting off with the edge case, if the position is less than 0, or okay, so it's not position, yeah. So if the position is less than 0 or position is greater than the size of the linked list, we can simply print that invalid position. Yeah. So now when we have gone out from here, so we can return. Yeah, so now if the position is equals to 0, that means we will simply call our insert at start function and pass it the data. And then for the else if case, if the position is equals to the size of the linked list, then we will simply call the insert at end function, because we are referring to the end of the linked list. And now for any kth position in the linked list, what we first of all need to do is that, so we will have an else case, and now inside this else case, what I need to do is that I need to first of all create a new node, again naming it as temp, and I need to store my head in a pointer, and I'm naming it as current. So now I'll run a for loop for int I is equals to from 1 till I is equals to 1, I is less than the position I plus plus. So now what we need to do is that we need to, okay, just a minute. Yeah, so now we need to move our current pointer so that we reach to the place where we need to insert new node. So for that we just need to update current for every ith increment. So current is equals to currents. Next. Yeah, so now after we have now reached the position, that means exiting from our loop, what we now need to do is that we now need to point this new node's next to be equals to the current's next right now, so that we are pointing at the correct position for the node to be inserted. And then simply we need to point the current's next to be equals to the new node that we have created, and this will simply insert the node successfully at any kth position. So temps next would be equals to currents next, so that both the nodes are pointing at the same position. And now what we need to do is that we simply need to update currents next to be equals to 10, so that our head always remains previous. And yeah, I forgot, we also need to increment the size of our linked list. Yeah, so this would be it for the insert at any position function. And now moving on to the next function. So now as you guys have learned how to insert in a node at any kth position in a linked list, you should also know how to delete a node at any position in a linked list. So for that, again, I will create a function delete at position, and I'll pass it the data. By the way, we do not need to pass the data, we only need to pass the position, so that we simply delete the node at that position. So again, we will have the same edge case. So if the position entered by the user is less than 0, or the position is greater than size, then we simply need to print invalid position and return. And now for the else, and now again for the if case, that if the position entered by the user is equals to 0, then what we would, so then if the position entered by the user is equals to 0, we would know that user is directly pointing to the head node. But we cannot like directly delete the head node, because if we directly delete the head node, we will simply just uh, we would simply be losing the head of the linked list, which is a bit problematic if you're dealing with a large linked list. So for that we need to create a temporary pointer that stores the head of our linked list. So why not to create a temporary pointer? I'll name it as temp, and it will be storing our head of the linked list. And now if the position is equals to 0, that means deleting the head of the linked list. So now as we have simply stored the head of the linked list earlier, so we just need to update it uh, to the next node, and then delete the temporary pointer that we have created. So we'll simply move head to be equals to the next head, and after this, now once we have moved our head one step forward, what we now need to do is that we again need to check that if the list is empty or not, because if our linked list only consists of a single node, so that would be our head and that would be our tail of our linked list. So what we now need to do is that we can simply assign tail to be equals to the null pointer, and then we need to delete the temporary pointer in which we have stored our head of the linked list. So now for that, what we can do over here is that we can again use an if case, that if the head is equals to null pointer, what we now need to do is that we need to assign tail to be equals to the null pointer, and then we need to delete the temporary pointer. And now for the else case, if that is not the case, we will then for example, if we need to delete the node at any other position, so for that what we need to do is that, okay, just a minute, it needed to be inside this loop. Yeah, so yeah, so now for the else case, what we need to do is that um, we can create another temporary node, and we can assign it to be equals to the null pointer, and then run a for loop equals to 0 till I is less than position I plus plus. So now what we need to do is that we need to, okay, so I need to rename it. Let us rename it as previous. Yeah, so node star previous, because otherwise we would just be conflicting these two. So now for this particular loop, what we need to do is that we need to assign our previous node to be equals to the temporary node that we have created earlier, and then move the temporary pointer forward so that we reach our desired position. And then if we have reached our desired position, what we now need to do is that we need to assign previous next to be equals to temps next, same as the case in what we did in the previous insert at any position function. And now we need to basically check that if uh, the next so now what we now need to do is that we need to handle the case that if the temps next is equals to null, that means if it is deleting the last node, we simply need to update our previous pointer to be equals to. So we would be basically updating our tail to be equals to the previous pointer, and then we would be deleting the temp pointer that we have created. So if our temp next is equals to null pointer, and we can simply comment that deleting the last node, that means deleting the tail of the linked list. So for this case, we need to assign tail to be equals to the previous pointer that we have created, so our tail pointer does not get lost. And then coming out of the loop, we simply need to delete the temporary pointer. Yeah, so this should be it for this function. I think I have handled all the cases for position equals to 0, for head is equals to next, for any position, and if it is the last node. Yeah, so yes, we also need to increment the size of our linked list. Okay, so we need to decrement it, pardon me. Yeah, so now moving on to our next function. It's a simple function. We need to simply search a data in our linked list. That, for example, we have a linked list that stores 1 2 3 4 5, and I want to search that on which position is number 5 located, or on which position is any other data located. So let's name it as int search. Yeah, so it would have a return type of integer, because we will be returning a position at which the data is stored. So int search in linked list in ll, and I need to pass it the data to be searched. So now what we need to do over here is that we again need to store our head in a temporary node, and then initialize our position to be equals to 0. And now we need to go to the till the end of our linked list to check where the position lies. So for that we will run a while loop, that while our temp is not equals to null pointer, what we now need to do is that we need to check for every iteration that if the data in our temporary pointer is equals to the data entered by the user. So if that is the case, directly we will simply return the position, and if that is not the case, we will move that pointer to the next and then increment the position so that we keep a track of so that we have a track at which position the data was. So for this particular while loop, we will use an if case first of all, that if the data that the pointer is holding is equals to the data entered by the user, we will simply return the position, and if that is not the case, then uh, temp is equals to temps next, and position should be incremented, and then eventually when we will have the position at which the data is located, it will simply return the position, and if the data is not present, we will simply return -1. And now as we all know that we are keeping a track of the size of our linked list for our ease, rather than writing a complete get size function for our linked list. So for now, to get the size of our linked list, we can create a function with the return type integer int size of linked list. And now inside this function we simply need to return size, what we have created. Otherwise we would have used a for loop and counted the number of nodes in our linked list. That becomes a bit tiresome. So now moving on to the next function, that is to display the first node of the linked list, displaying the middle node of the linked list, and displaying the last node of the linked list. You can also call it as FML, that means first, middle, and last. So I'll name it as FML though. So void return type display FML. So basically what this function will do is that it will display the first, middle, okay, so spelling mistake again, middle and last node. So for this function, we first of all need to check that if the linked list is again empty or not. So if the head is equals to null, we will simply print that list is empty. And now after this, we will simply return. And then what we can do is that we need to store uh, the first, the middle, and so we basically need to create 3 pointers: a pointer pointing to the first, a pointer pointing to the middle of the linked list, and a pointer pointing to the last of the linked list. So for that we will create 3 pointers: first, middle, and last, and we will store our head pointer in them so that we traverse to the end of the linked list. So naming our creating our pointers, so node star first is equals to head, and node star middle is equals to head, and node star last is equals to head. So for the last, we need to assign it to the tail of the linked list because we can directly print that out. And we also need to make a count variable to keep the track of our elements. And now creating a temporary pointer that we will run in our while loop to store the head of the linked list. And now over here again we will run a for loop, we will run a while loop till the end of the linked list. So while the temporary pointer is not equals to the null pointer, that means the end of the linked list, we will check that if the count by 2 is equals to 0, that means the remainder, that means we get an even number count. We will simply update the middle pointer, and then if that is not the case, then we will simply update our temporary pointer to move forward in the linked list and increment count. And then through this while loop only, we will simply get our positions for all our first, middle, and last elements in the linked list. And then simply we will print that the first node in linked list is the data that the first pointer would be holding and ending it up with the endline function. Yeah, so now we need to basically check that if the count is greater than 0, we will print the middle and the last node. So cout middle node is and after that we will simply print that the last node in our linked list is last data. Yeah, so this would be the case if the count is greater than 0, and if the count is not greater than 0 for the else case, we will simply be knowing that the linked list only had one node, so we will simply print that no middle and last node in the linked list. Yeah, so this would be it for this function. And now moving on to the next function, that is to update the node data at any position. For example, you have given a linked list with the node containing the values 1, 2, 3, 4, 5, and I tell you to update the node data to be equals to 4 at third position. So for arrays it's really simple, but for linked lists you need to work with pointers basically. So I'll name it as my function as update at any position, and we need to pass it the data, and I need to pass it the position at which the data needs to be updated. So again, our basic edge case that if the position is less than 0 or the position is greater than size, so you have entered an invalid position. So now if the position is valid, then we simply need to traverse to the position respectively and update the data for that specific position's nodes. So storing our head node so that we run a for loop till the position. So print I is equals to 0, I is less than position I plus plus. Okay, so position needs to be corrected. And we simply need to go to the respective position. And now once we have reached over there, we simply need to update it. Yeah, so this would be it for this function too. I don't think I have missed anything on it. It is basically handling all cases. Yeah. So now I'm pretty much ending this. We have been done with 184 lines of code. So yeah, so why not to create a function that reverses a linked list? In arrays it's really easy, but in linked list you need a bit work to do. So why not to create so basically we will be using a two pointer approach for this problem. So why not to create two node star previous equals to null, and the current will be equals to head, assuming it's a linked list with only one node, and the next should again be initialized to be null. Yeah, so now what I need to do is that I will run a while loop while our current is not equals to null. That means till we do not reach the end of our linked list, we would simply be updating our next pointer to be equals to currents next, and then we will update our currents next to be equals to the previous pointer, so that we go in a backflow order, and then we need to update our previous to be equals to current, and then again need to update our current to be equals to the next. So we go in this way and then again go from top to bottom. So we start off from bottom to top and then we go from top to bottom. And then after the while loop, we simply need to update our head to be equals to the previous pointer that we have created. Yeah, so running a while loop, that while current is not equals to the null pointer, what I now need to do is that I simply need to update that next is equals to currents next, and current next is equals to previous. And now after this we need to update our previous to be equals to currents next, and current to be equals to next. Yeah, so this should be it. And yeah, I need to update my height to be equals to the previous pointer. And we also need to update our tail pointer. I think we can do it over here, that tail is equals to the head of our linked list, and this would be it for this function. And now moving on to the last function of our linked list, that is the display function. That is relatively easy. So we basically need to have a current node that stores the head of our linked list, and then run a while loop, that while our current is not equals to the null pointer, we simply need to update current is equals to currents next. And okay, so I just misplaced it, and see out current data for every iteration in this linked list. Yeah, so this should be it for our display function as well. So okay, I think I made a mistake. I don't know why I did this. I need to print it before updating the pointer. Yeah, so now writing the main function. So to test that our code is error and bug free. So for the main function, let me create a linked list and its object. I'm naming it as L1, and I will be inserting the node at tails in order. So L1 dot insert at end. Yeah, so I would be inserting 1, 2, 3, and 4. Yeah, so after this, now we can insert also. So L1 dot insert at start. I can insert 0, and why not to display to see if it is working or not. Yeah, so we have our linked list being displayed correctly. So now let us use and test the functions that we have created. So for the fifth position, I need to insert the number 5 so that we get 5 over here. So L1 dot insert at position, at fifth position I want to insert 5, and So why not to insert a few more terms? Why not to insert 10 at 0th position, and why not to insert 7 at position 3? I think this should be good, yeah. So again, displaying the linked list. Yeah, so you guys can see we have successfully inserted 10 at the position 0, and then 7 at position 3, and 5 at position 5 for the linked list. So again, to clear you guys, inserting at any position does not means to update at any position. Inserting at any position just means to insert the node by pushing the current node one step forward and then taking its place. It does not mean to update the node at any position. I'll show you guys how update function works. So now we have, as we have inserted the nodes at different positions, why not to delete a few nodes at positions? So L1 dot delete at position. So I have inserted 3 nodes at different positions. So why not to delete 4 nodes at different positions? So positions would be 0, 1, 2, 3, 4, 5, 6. We have 6 positions. So deleting at position number 6, deleting at position number 0, and deleting at position number 5, and deleting at position number 2. So let's see what we got. Yeah, so we have an ordered linked list 0, 1, 2, 3. So the delete function is also going perfectly fine. So why not to get the size of our linked list? Cout size of linked list is so for our current linked list we have a size 4, and this is correct. And now why not to search a node's data? So what should we search? We deleted at position 2, so why not to search for 2 in the linked list? So we have 2, yeah, 0, 1, 2, 3, yeah. So let's create a int s is equals to 2, the number we want to search in our linked list, the data to be searched basically. And why not to store the position, that int position is equals to list dot search. What was the function's name? Yeah, search in ll. And why not to pass it s? Yeah, so what we can now do over here is that if the position is not equals to -1, that means that if the data is present in the linked list, we can simply print that found at position and our function variable's name was position. And if that is not the case, what we need to do is that we need to simply cout data not found, not downed, found. Yeah, so this should be it. So now let us check. Yeah, so 2 is present at position number 2, 0, 1, 2, 3. Yeah, so what we are left with now is what are the functions I created? Reverse function, update. Yeah, we are left with this update at any position function and the display first, middle, last. So now for why not to basically display the first, middle, and last node at first. Yeah, so the first node is 0, the middle node is 2, and the last node is 3. Yeah, that is right because it's 1, 2, 3, 4, first, last, and the middle. So why not to update? So for our second position we have 1 present, so why not to update at position number 2, that update at any position I need to update. So why not to update it by 20 at position 2 and then display the linked list. Yeah, so 2 got updated by 20 in our linked list. And now why not to reverse the linked list? So reversing would give us basically 3, 20, 1 and 0. So L1 dot reverse and L1 dot display. Yeah, so okay, what is wrong over here? What wrong would we did? We reversed the linked list and then we displayed it. Why is not it? Why it isn't displaying the linked list after reversing it? Let me check the function. Yeah, so we declared it to be equals to null. I declared to be equals to head, next to be equals to null, tail to be equals to head, and while current is not equals to null pointer, so next is equals to currents next is equals to previous, and previous is equals to, okay, so previous needed to be equals to current. I don't know why I did this. And current is equals to next. Yeah, so I think we should be good to go now. Yeah, so as you guys can see, our linked list is reversed. We are printing it in 3, 21 and 0. Yeah, so this is it guys. I have pretty much covered most of the functions that are required to be having a good understanding of in a singly linked list. I did not actually want to cover the part where we overload the assignment operator or the copy constructor or the destructor part. It's relatively easy and it is important though. You need to know why we need to use an assignment operator in a linked list, why we need to overload it, and why we need to use a copy constructor in our linked list, because whenever we use a class that uses dynamic memory allocation, we need to overload the assignment operator and use a copy constructor so that we do not cause memory leaks and dangling pointers. Because what happens is that if you assign an object to a new object, so it will copy the data, but when you make a change in one object, what it does is that it automatically makes same changes for the other linked list object too, and that is what you do not want. So for that reason you use operator overloading these heimat operator and using a copy constructor for any class that has dynamic memory allocation. So on this note, I end this video. Hoping that you guys had a good understanding of how the linked list actually is, how the linked list actually works. And I would not be actually creating a video on a doubly linked list. I think making a video on single linked list is enough for me to make you guys understand how a single linked list is actually. And I deliberately basically used a tail pointer. It is not necessary, but it is actually very useful. And as I think that if I have made a video using a tail pointer for a linked list, you guys now should be able to implement a doubly linked list on your own, because you, for every function, you just have to keep so for example, over here in our node class we have only our next pointer, but for the single linked list, but for the doubly linked list you also need to have it previous pointer for your node class, so that you need to update it in every function. So that is relatively easy, and I'll meet you guys with the next video soon. So take care, guys.